Hey, I'm Adam, and today you're going to be blown away by the field of material science, all about how we can use materials to solve problems. The world's major advancements have been led by material science. The Industrial Revolution being led by metals, mainly steels. Think about where buildings would be without them today. Aluminums, which made air travel possible. Polymers like plastics, which are long chains of hydrocarbon atoms. Ceramics like glass, and creating the transistor at such a small size. Where would phones and computers be without them? And the final type of material you have is composites, combining these types of other materials. In material science, we look at key properties like insulation, conduction, ductility, strengths, and from there decide on what material should be used for certain jobs. A material's properties are largely determined by their structure. For example, the transparency of glass is all based around the atom and how the protons, neutrons, and electrons are arranged. Given the certain properties we need for a job, we can determine the material and then engineer it using material engineering. A real-life example would be cars and how they're designed to have an accordion-like rhythm, so when you crash, you don't take most of the impact. And what's next for our planet is likely to be led by material science. So what's gonna be the next big change for the world? Well, energy usage sucks, so why don't we just make a battery to power the entire world? Yeah, what do you think about that? Hey, how about you? Hello? Man, guess I just left them too speechless. What's that? Drug delivery? Using certain materials to get drugs safely to a certain place in the body? I hope you do be absorbing all my energy. Or else maybe we may need a better material for solar panels so they could absorb more energy. A huge area of material science that's been skyrocketing is nanotechnology, looking at things on the nano scale. Think about if you took your good old pencil and put some tape on that graphite tip, took the tape off, and then dissolved the tape. You would have graphene, a single layer thick material. Some of its key properties are its strengths. This one layer thick piece of graphene can support the weight of a whole soccer ball. It's also extremely conductive. Who knows, graphene elevators to the moon may actually become a reality. The possibilities are endless, but the way we're finding materials now is so slow. And these people in other industries don't have a good idea of what certain materials should be used. For example, in medicine, in energy storage. And that's why things like machine learning are at a forefront, looking at the properties we need for certain situations and classifying the best materials for them. You can check out the Materials Project, which was launched by MIT, a site where you can go and find the best materials right now. Okay, but what if there are no materials that do the job? Well, just make one then. Exactly. Think about if we were able to take the structures of certain materials and how they correlate to their properties, and then use things like GANs to create new materials based off new structures that correlate to the best properties. If that wasn't enough, take quantum computing, where we can simulate how materials will interact in the real world, and therefore which ones are best for the job. Finding the right material for that hyperspace spacecraft just became a lot easier. With the new opportunities for material selection, we want to bring what the internet did for information to materials for every single industry. So, what are you gonna completely reinvent with material science? Still too much for him.